Let's jump right in and introduce our first keynote of the day, Building Modern Analytic Applications with Apache Druid. Please give a warm welcome to our speaker, none other than F.J. Yang, CEO of Imply and one of the original authors of Apache Druid.
Hello, everyone, and welcome to Druid Summit. For those of you that don't know who I am, my name is FJ, and I'm one of the original authors behind Apache Druid, as well as the co-founder and CEO of Imply, which is a technology company that both develops Apache Druid as well as offering a commercial product around the core engine. We have a great lineup for you guys this year. In the keynotes, we actually have John Merlino, who's the current PMC chair of Druid. He's going to present the roadmap for Druid. We have a fireside chat with the original founders of Druid, and we're going to talk about everything we've learned on our journey. We also have Jay Krebs from Confluent, who's going to deliver a keynote about how Confluent uses Druid, as well as his views on the data space. As for me, I'm going to give you guys a talk on building modern analytic applications with Druid. And this talk is really about some of the history of Druid and how we think about Druid and where it belongs in the overall data space. So there's many different types of users in the audience. There are folks that have been using Druid for many years, as well as I'm sure many newbies that have heard of Druid for the first time and are kicking the tires of the project today. I want to share with you guys a little bit about the origins of Druid. Druid is actually started in late 2011 by an engineer called Eric Cheddar, who's actually currently the field CTO at Imply, and you're going to hear from him a little bit later. Eric actually hired me, and a couple months after he started the project, I started coding on it as well. Why Druid was created was to power a user-facing analytics product that was designed to be able to load very large and complex data sets and allowed end users to be able to arbitrarily slice and dice those data sets. There were very interesting technical problems that we were trying to solve when we first started designing Druid. One was around concurrency. How do we support thousands, if not tens of thousands, if not millions of queries at the same time? How do we guarantee that those queries return very, very quickly? And how do we make sure that the data that the end users are working with are immediately visible after events occurred in their systems? So Druid started about 10 years ago, and over the course of the last 10 years, we've seen tremendous growth in the community. Today, we have more than 7,000 community members. We have more than 400 active contributors. And we've done over 450 releases since the code was initially open sourced. And I'm very proud to say there's more than 1,000 companies that are using Druid in production today to power all different types of analytic applications. There have been many milestones since Druid was first open sourced, and I just want to highlight a couple of them right here. So Druid was first open sourced under the GPL license in late 2012. In approximately 2013, we did our first really versioned release of Druid. The early versions of Druid were not super great. They didn't have any documentation. There wasn't much fanfare, but we believe we had created something of value. In 2015, with a small but growing community, Druid became Apache licensed, and Imply formed as a company as well. Since then, we've been actively developing on Druid, making it easier to use, making it the fastest analytics database in the world, as well as adding many key features. For example, in 2017, we added SQL support. In 2019, Druid became an Apache top-level project. In that same year, we added dependency-free batch ingestion, and the year after that, we rebuilt our entire query engine to be vectorized, as well as adding enterprise-grade security. Today, as I previously mentioned, we're lucky to count over 1,000 companies in production that are using Druid. A lot of people have asked me over the years, why do we build Druid? What is its value and what is its place in the modern data world? And the way I like to answer this question is to talk a little bit about how I've seen the evolution of various types of data systems. If you guys remember, in the late 2000s, a lot of internet companies, a lot of high-tech companies were struggling with problems around storing and processing data at scale. And these companies, notably Yahoo in particular, ultimately open sourced Hadoop. And Hadoop was a system that was really catered towards being able to store large amounts of data, as well as being able to process large amounts of data. Today, I'm sure many of you guys are using data lakes in the cloud and still leveraging tools like MapReduce or Spark in order to process your data. In the 2010s, notably the late 2010s, a different set of problems started materializing. People started asking questions and trying to solve problems like, how do I cost efficiently query all this data that I have at scale? And this led to the rise of decoupled SQL query engines. These are modern data warehouses like Snowflake, BigQuery, and many others. And how these data warehouses work is they separate compute and storage, which allows you to store a whole lot of data and pull that data as is needed for queries in a very cost-efficient manner. So over the last 15 years, we've really solved storing data, we've solved processing data, we've solved querying data. Nowadays, I hear a lot of people ask the question, how do I disseminate the data that I have to a wide audience? How do I create modern analytic applications where anyone can access data and make use of that data? And this is really where Druid provides its value. Druid belongs to a class of databases that are really designed for real-time workloads, getting data in really quickly and getting data out very quickly. So back when I was a developer and when I was working on Druid, one of the main motivations of Druid was to power a user-facing analytic application. And as a developer, I faced three main challenges in order to build that application. And I think these three challenges are very much what the community still tells me that they're struggling with today. The first challenge is around supporting unlimited users. When you're building an analytic application, you hope that application gets used by many, many different types of users, thousands, tens of thousands, and even numbers beyond that. You want your application to be very interactive, so as users click on buttons in that application, they're able to immediately see results that are based from their actions. Lastly, modern analytic applications should immediately reflect data as it's occurring. So most modern data pipelines are becoming stream-oriented and fully streaming and real-time, and analytic applications should no longer wait hours or days in order to reflect the data as it's getting created. I want to go a little bit more into detail about the challenges that developers face as they're building analytic applications. The first is supporting large amounts of concurrent users. Previously, data was really only accessed by data analysts who were highly specialized as their jobs, who knew SQL really well and could write very complex SQL queries. Today, more and more parts of the business actually require data and require data in order to make decisions. So the people that need data and use data has been expanding very rapidly. When you have many different types of users try and access data, they also generate queries at very high concurrency. And if you have the wrong type of system powering your application, it can get very cost prohibitive very quickly in order to support very high query workloads. For example, many modern cloud data warehouses actually charge you per query. And those costs of using data warehouses increase very quickly if you have a very active application. The second problem that I faced as a developer building an analytics application was to build an interactive experience for end users. When I say interactive, what I mean is when an end user interacts with an application, that application is very responsive. The end user clicks a button, the application updates to reflect what the end user is trying to do. With a lot of legacy systems and with data warehousing-like systems, you can have applications that don't feel interactive. You can have this spinning wheel of death where users basically wait minutes, if not hours, to get results to some of their questions. And these problems are compounded much more when data volumes increase and the complexity of queries and the complexity of data increases as well. Finally, one of the biggest challenges I've heard about and I've experienced myself with building modern data applications is to have immediate visibility into data. As I mentioned previously, a lot of modern data pipelines have become very stream-oriented. You no longer have to wait hours in order to see what's been happening in your data. You have immediate visibility in your data pipeline, so your application and database should also reflect the immediacy of data. And Druid is a system that can actually handle both streaming workloads as well as batch processing workloads as well. So Druid is really built from the ground up to power modern analytic applications. And another common question I've been asked is, what is Druid's secret sauce? What makes Druid Druid? How does it do things better than other systems out there? And I think there's three main components to Druid's architecture that really give it its power. The first is Druid has very highly efficient computation. It takes raw data and converts it into a data format that's highly specialized for analytics. It does very intelligent compression. It also does approximations on queries where appropriate. This is completely optional. Another core concept of Druid's architecture is that it tries to minimize data movement. So it has a scatter-gather architecture where storage and compute are co-located. And it also executes single-stage query processing, which really just means we're trying to put compute and storage as close together as possible so we can run queries as quickly as possible. Lastly, Druid is optimized for both streaming and batch ingestion. It has a pretty novel way of loading data, one that is completely lock-free, so you can throw a stream of however many events that you want at it, as well as throw batch files of whatever size you want at it, and it's going to be able to handle it at any scale and latency. Druid Today has been used to power many different types of data applications and many different companies. As I mentioned, Jay Krebs is going to give a keynote later on about how Druid is used at Confluent, where it powers a health and observability product line. Druid Today is used at Twitter, where it powers the MoPub Analytics product. MoPub Analytics is a product that allows Twitter's advertisers to understand the performance of their advertising campaigns. Druid is also used at Atlassian, where it powers analytics for the Confluence product line. Confluence is a very popular wiki system, and Atlassian recently launched a product where you can have analytics on how Confluence is getting used within your organization. And Druid is one of the core engines behind that product. The way I think about Druid and its place in the data world is very simply, I think Druid is a database that powers analytic applications. And its direct parallel and kind of the other side of the coin are document databases that power modern transactional applications. So for example, systems like MongoDB and Cassandra and DynamoDB and Couchbase are great for OLTP or transactional or web application-based workloads. But a system like Druid is really built from the ground up to power analytic workloads. Workloads in which you have to sum or aggregate data, where you have to group and filter on data as well. We've come a long way with Druid. The community is much larger than it was before, but we still have a lot of work left to do. I think about the future of Druid in really three main buckets. The first bucket is around being able to support more types of queries. We hear feedback from the community that they would love for Druid to be able to support bigger subqueries, support broader types of joins, as well as being able to do computations like exact count distinct a whole lot easier. And we take all of that feedback and we think about how our roadmap can deliver some of those items. Another bucket of asks and areas that we can really improve is ingestion ease of use. So we've thought about simpler ingestion APIs, fewer tuning and configurations for ingestion, as well as better support for native JSON, particularly nested JSON. So our hope is that in the future, you can throw any arbitrary JSON blob at Druid and it's going to be able to understand it, as well as create the appropriate data structures to handle it. The last set of features and capabilities are around increasing operational ease of use. Druid, out of the box, is a multi-process and multi-service system, and we've thought a lot about how do we simplify tuning and configuration, how do we potentially reduce some of the processes and dependencies, how do we make Druid as a system much easier to use. We started Imply in late 2015, and one of the reasons why we started it is because we believed that there had to be a dedicated organization that was focused on delivering the vision of Druid. So today, Imply still actively works with the community in building out Druid. It works with the community in learning about what use cases Druid can do and what use cases it can do in the future. Supporting the open source community is still one of the core values at Imply. And if you're ever interested in more about the work that we're doing at Imply and some of the Imply-only capabilities that we're building, I'd be happy to find some time to chat with you guys. If you guys want to learn more about the future of the Druid experience, I highly recommend that you attend Jian's keynote talk, where he's going to go into detail about an exciting new project called Druid Shapeshift. It's going to be one of the most major projects we've ever undertaken as it relates to Druid. So with that, thank you guys again for attending my session. Thank you for attending Druid Summit. Hopefully next year, COVID will be over and we'll be able to do this in person again. But regardless, really appreciate you guys making the time. Thank you.